Hello everyone, and welcome to our first lecture about calculating power in circuits. This is a really interesting topic, and you may recall that when we started this course, I mentioned that the main reason that we calculate voltages and currents are precisely because we want to calculate power. So let me go ahead first and define this. And I just want to probably assume that this is something you have already seen before from basic physics courses. In all my experience in teaching at the university, I have found that when I ask people, how do I calculate power, if I know the voltage and the current of a device, then almost everyone will say, well, you just multiply voltage with current. But when I ask the question, why is that, the answers are not as easy. So first of all, let me remind you why when you calculate the power as voltage times current, you're doing something correctly. So you may recall that if I take V and I multiply this with I, essentially I'm taking the rate dW dQ. This is precisely the definition of the voltage. The definition of the voltage is the amount of energy I'm spending to move a charge against the electric field per unit charge, times the current I, which is dq dt. So that means the amount of charge I'm moving per unit time. So I can go ahead and cancel the dq's, and I find out that immediately the result is dw over dt, or nothing else but the rate of change of energy, which of course equals power. So as you can see from this simple calculation, multiplying voltage times current certainly results in some watts, some power, and definitely I'm doing something correct here. However, it's not as simple as that, and this is where this but is coming from. One of the things that we have to be very careful when we calculate power is we have to answer not just how much is the power, but whether the power is consumed by a device, or whether the power is delivered by a device. In other words, is this device consuming power for us? Is it maybe like a heater that takes electric power to generate heat, so it's consuming electric power? Or is this device rather delivering power to the circuit? Maybe it's the battery of your cell phone that when your cell phone is working is actually delivering power to the circuit. So in a very similar way as to the current, where we had to calculate both its value as well as its direction, and the voltage, where we had to calculate both its value and its polarity, in the case of a power, we have to calculate both its value and whether this power is consumed or delivered. It's not enough to simply give the answer, the power of this device is 2 watts. People will ask, is this consumed or delivered? So we have to be a little bit more precise in calculating this, and this is what I'll try to show you in the remainder of this lecture. Now, let me first state the results, and then I'll go ahead and explain them. First of all, I'd like you to notice that whenever you're talking about the voltage difference or the voltage polarity across a device, you may have also a current that flows through this device, and you may have 2 different scenarios. Either this current will be entering the device from its positive terminal, or this current will be leaving the device from its positive terminal. These are the 2 different cases. With blue, I have indicated here the case where the current enters the device from the positive terminal, while the case to my right is indicating the current leaving the device from the positive terminal. In both cases, the V times I will actually give me power. In both cases, if I multiply the voltage difference V with the amount of current that flows I will get power. However, in the first case scenario, I will get power as the consumed power of this device. In the right case scenario, I will get the power delivered by this device. So let me say this again. V times I in any case gives power. But if the current is entering the device from the positive terminal, the result V times I signifies consumed power, while if the current is leaving the positive terminal, then the device is delivering power. In order to say things a little bit more concisely, we actually give names to these different situations. This is called the passive sign convention. And by these words, we mean that the current I is entering the device from the positive terminal, while this one is called the active sign convention. And by that, we mean that the current is leaving the positive terminal. So when you hear me talking about passive sign convention, I will refer to the situation to the right, to the left, while when I talk about active sign convention, I will refer to the situation on the right. So whenever you have a device in the passive sign convention, V times I will signify consumed power. Whenever you have it in the active sign convention, it will signify delivered power. Now you might say, why is that? Can you prove to me that this result is correct? Well, yes. So let me show you the situation for the passive sign convention, and then the proof is exactly the same or exactly analogous for the active one. So remember that when we talk about current flow, we really imagine positive charges flowing in the direction of the current. So if I imagine a little bit of a charge of dq flowing through this device, recall that when I have plus and minus, I really mean that this point here is at a higher potential than this one. Or in other words, the top of the device with the plus sign is at a higher energy than the bottom of the device. Essentially, that means that if I'm a charge sitting at this point, I am sitting at a higher energy than if I'm a charge sitting at this point. Well, that's exactly what happens with this current flow. This current flow is actually driving positive charges from the top, which is the plus, to the bottom, which is the minus. In other words, as the charge is going from the plus to the negative sign, it actually loses energy. So it was sitting at a high energy point, now it's sitting at a low energy point. That energy must have gone somewhere. Well, where did this energy go? This device consumed it. So that is precisely why when you have a device in the passive sign convention, the product V times I signifies consumed power. For example, let me give you here a device where the current of this device is, let's say, 2 amps, and the voltage drop across this device is 3 volts in the indicated direction. Is this device in the passive sign convention? Of course it is. The current is flowing into the device from the plus sign. That means if I multiply 3 volts with 2 amps, I will get 6 watts, and that means this device is consuming 6 watts. If I had exactly the opposite sign convention, the active one, then V times I would have given me the device, the amount of power this device is delivering to the circuit. So you will see more examples in other videos. So thank you for staying with me in this video, and we'll see you next time.